Jai Hind all of you. I am Dr. Aditya Pratap Singh, Associate Professor in IT Department of Ajay Kumar Garg Engineering College. Today we are going to discuss a very interesting topic, file manipulation in C, or sometimes we also call it file handling in C. We were previously covered some programs for control flow, for branching using loops. We covered the topic like arrays. We covered the topic like use of pointers. And today, when you will make program, then you will see something which is being stored permanently on the storage. So let's first try to understand what is file, which we are going to manipulate. So if we talk about a file, then we are referring to a file which is stored in secondary storage. Till now we were doing programming which was being done in the primary memory, and that is a temporary storage. So whatever data, either in the form of structures or in the form of arrays, we were storing, that was being stored in the temporary memory, that is RAM. And when the program is completed, the data has also been lost. So if we want to store some data permanently, which can be utilized later, that we need to store in the permanent storage, that is generally referred as secondary storage, like in the hard disk. So file is basically a collection of similar records stored in the secondary storage or stored in the permanent storage area for being accessed later for our programming. So it is a named collection of data. We are also providing some name to that collection of records. And these records, I am saying that collection of similar records. Like if we want to store like data of my students of a class, so that file is containing, like I am giving a name studentdata.docx. So that file is containing the data of student of my class, their names, their roll numbers, their marks, their age, their address, their mobile number, something like that. Or we can store it in Excel also. Like if we want to store a picture, a group photograph of my student, so that we will store in a different format. So it is a collection of similar data that represents a picture. Or if we want to collect the information of employees, so that that file is containing similar records, like records related to employees. We want to store the nodes. Nodes means like audio nodes. So that becomes an audio file that is containing a music, that is containing some recording audio of something. So that is containing similar kind of data. So for such data, we create a file that is being stored at the secondary or non-volatile data storage. It can be used when the computer is off, and when again we are using, that is still available for further use. So how the file is stored? So let's try to understand how file is being stored. It is stored in the sequence of bytes. The bytes which are containing the data will be stored sequentially and logically contiguous. I am saying logically contiguous. Logically contiguous means physically there may be multiple parts of file stored at different locations, but every part is connected with one another. Like file part 1 is having the next address of the location where next byte is stored. You encountered such thing, or you experienced such thing, like sometimes we download the file using some download manager, and it is downloading that file parallelly in different parts. So these parts are being stored somewhere in the memory. Later on, they all are integrated and form a single file on the disk. But actually, physically, different parts are scattered in the disk. but they are logically connected with the address. Sometimes you heard about the terms like fragmentation, defragmentation. This is the cause of this fragmented files, because file is scattered in multiple parts in the disk. So that file is basically a discrete storage unit for data in the form of stream of bytes that is being stored as a stream of byte, and every file is having some information characterized with the starting of file, sequence of bytes that is actual data, and end of file. So every file is containing three things. Like first thing is metadata. What is metadata? Metadata is basically data about data. So what is metadata in the terms of files? So that metadata contains the name of the file, the storage location of the file, the access rights of the file, the type of the file, and some security information. That information is being stored in the form of metadata and attached at the beginning of file. So this portion is basically containing actual data, and the last byte which is stored at the end of the file, that is EUF character. EUF character is a predefined constant in C programming language. We can use directly the name or the keyword EOF, and this is having a value, ASCII value of 1A in hexadecimal, and it can be represented with the use of control plus Z. So control plus Z creates EUF character. So sometimes in some editors you can see, like in Linux or Unix mode, when we want to close the file, we need to press Control Z. That means we have given the end of file character and the file will be saved and stored. So while reading a file, the EUF character can be checked to know the end. Like when we are going to manipulate the file, during that manipulation, we don't know actual number of bytes stored in that file. We don't know the size of the file. So what we can do, we can read byte by byte and check for EUF character. If we found EUF character, that means the file is completed. So in this situation, we can check for EUF character in a loop, which we will see later in the presentation or later in the video. So now talk about the types of files. There may be different types available, but here in respect to the or in reference to the C programming, we can classify files into two types. One is text files. Text files means that is containing some character, numeric or some special characters data. This kind of file, every data is represented in the form of ASCII code that can be read with the help of C programs, and so the data is being converted into ASCII code. So sometimes if we use some other kind of data and we treat it as a text file, so that may give wrong results. Second type is binary files. In binary files, we are not converting the byte into any kind of data or any kind of code. We are simply reading the sequence of 0 and 1s, giving as it is. So these kind of file contains non-ASCII characters, non-ASCII data. That means no kind of conversion is being done during manipulation of file. If we will convert it into different format, then the actual content will be distorted. So such files can be image file, audio file, video file, or some executable codes that is also in the form of machine code or 0/1. So such kind of files will be manipulated in the form of binary files. So now let's start with the file handling. So these are some typical operations on the file in C programming language. Like we can open a file for manipulation. So this operation contains to open a file to store or retrieve data available in that file. Another thing is to read operation. Read operation is basically when we are reading content from a file. So we are using file as a input. Write to file means the file is used as output. So we are writing the content onto the file. Closing a file, the file which we have opened needs to be closed. When the work is done, we need to close that file, because when we open the file there will be a lock taken on the file for our operation, and when the operation is completed, that lock has to be released with the help of close. Access operation is referring to the random access of data in the file. In normal, we access the file in a sequence of bytes. So what pointer is moving one by one byte in a sequence of bytes. So if we want to get data randomly, then that random access of file can also be possible. That operation is called access operation. So let's start with the opening and closing a file. So these are some file commands. So these for opening, closing or file manipulation. So all these functions are available in the stdio.h header file, which is referring to the standard input output. So this header file contains the operations or the inbuilt functions related to file handling also. Another thing which we require for file manipulation is a special type that is called file, capital letters, file in capital letters. It is basically created by the compiler, and it is a kind of structure, and a type definition of it is given as a name file, so that we can utilize. This is not a primary data type kind of thing. It is a library type which is available to us to manipulate the files. So this file type, we will create a pointer. So this kind of pointer is capable of pointing to a file, pointing to a secondary storage file. So to open a file, there is a function called fopen. So fopen function takes two arguments. One is the file name and another is the mode. Mode we refer to like in which mode we are going to open that file. Like in what kind of operation we are going to perform. Like if we want to read the data from the file, then we will open it in read mode. If we want to write data onto the file, we will open it in the write mode. And the fopen function returns a file pointer. So it returns a file pointer. fclose is a function to close the file. That means the locks on the file will be released and the pointer will no longer refer to that file. So this is the form fclose. We will pass on the file pointer as a argument and it will return integer value. So let's try to understand the fopen function. So the first argument is the a string of characters indicating the name of the file, that we can give the name of the file like abc.txt, pds.txt, myfile.c, myprogram.c, any kind of file we can pass, or we can also pass the complete path of the file that file. If that file is not available in the current directory, then in that situation we can pass on the complete path of that file. So now second argument is the mode of file opening, mode of the file opening. So in this situation, in this argument, we are going to pass a string which will tell the compiler that file is to be opened in which mode. Like if we pass R, so file will be opened for reading and reading lock will be taken. If we pass W, W is referring to write. So we are going to open a file for writing onto that file. A is for appending. Appending means we are going to add some content into that file. So depending on the operation, the file will be opened. Like if we are going to open a file in read mode, then in the read mode, if the file is available with the content, file will be opened. If the file is not available, that means file is not having any content. So such kind of file will not be opened. The read operation will fail if that file is not pre-existing. System will not create that file. If the file is pre-existing, it will be opened for reading. If file is not existing, that means there is no data available in that file. So there is no kind of read operation can be performed on that. So now if we are going to perform operation using write mode, in the write mode, the C compiler, what will happen, the operating system will open the file. If that file is existing, the contents will be deleted. That means we are going to write onto that file. So what will happen? Overwrite. If it contains some data, that data will be lost, and whatever we are going to write, that new data will be overwritten into that file. If the file is not existing at all, then system will create a new file in the current directory and or the specified directory and then start writing onto that file. In append mode, the writing on the end of the file, it is also going to write something, but it is not deleting the previous content. It is adding the new content into that file. So this, if the file is not existing, it will create the file and add the content. If the file is existing, then it start writing from the end. Now let's try to understand where the pointer will start. For reading operation, we will start from the beginning. We will start from the beginning because reading will be started from beginning. In case of write operation, what is going? If file is not existing, then it will create it. If file is existing, content will be deleted. So it is also starting from beginning. Write is also being started from the beginning. And in append mode, what is happening? If the file is not existing, file will be created, then it will start from beginning. If the file is existing, then the content will be added at the last. So we start from end. Pointer will start from the end, and this end will be the first byte if it is created right now. In case we are working on binary files, then we use like RB, WB, and these returns a special value null to indicate that if it could not open the file. Fopen function will return null if it is not able to open the file, like file is not existing and we are opening in read mode, like we are not having permission to store any file into the specified place, then in that situation also it will give null. So these are some form of modes, like we can use like R plus. Also R plus means read is major, but reading and writing both operation can be performed, but read is major. So what will happen? It will not create the file. If file exists, then the operation can be performed. W plus means writing is major, then you are allowed to do writing and reading, but the properties of write mode will be followed. A plus means it is available for reading and writing, but the properties of append, like it will start from end. So such kind of properties will be followed in case of this. If we are working in binary mode, then RB, WB, AB, RB plus, WB plus, AB plus, such kind of modes will be allowed. Or we can also write like R plus B. That means read in binary mode, W plus B, write in binary mode. So that kind of file opening mode can be used. So to open a file, we used to create file using fopen function. If the file does not exist, open for writing or append, then it will be created. Opening an existing file for writing causes the old contents to be discarded. So let's have one example. Let's see. First thing is we need to create a pointer of type file to represent a file. We have stored a file name like file2.dat in a character array file name. So file name and fptr is the pointer. So we can write fptr equal to fopen and the file name and mode. This is mode. So mode we are using here is write mode. What will happen now? If file is existing, it will be created and the data will be lost. If file is not existing, then a new file with the name file2.dat will be created. Whenever we open a file, always remind to check whether the file is open or not. Before performing any kind of operation, what we need to do? We need to check. So to check, we can check if fptr is equal to null. That means file is not opened, file is not created, file is not available. So if it is returning null, that means there is an error. So we are here giving an error in creating a file and exit 0. Otherwise, we will write the code for file manipulation. So these are some functions which can be used in file manipulation like fopen, fclose. GetW function is for reading an integer from file. PutW function is for writing an integer to the file. fgetC function is used to read one character from the file. fputC function is for writing one character to the file. Getas reads line from keyboard that we can store in the file. Puts writes line to the output screen that we read from file. fgetas is for specialized for file. So fgetas function reads from a file and one line at a time. That means it reads up to new line character. And fputs function writes string to a file. So the syntax of fgetas, it uses one buffer, then size, and then the pointer through which it is reading from the file. Buffer means it will read from the file and store in this buffer. Size refers to the what number of bytes we are reading from file at a time, what maximum number of bytes we are reading from the file at a time, because buffer size is limited. So we can specify like if buffer is of size, then we specify that these number of bytes will be read at a time from the file. So similar in the fputs function, the pointer through which we are writing to the file, and then we are giving some data, or here we can pass the pointer to buffer also, or we can pass the buffer which is containing data. Another function is FEOF. FEOF function checks whether the end of file is there or not. And fgetchar is reads one character from the keyboard. fprintf, it writes the formatted data to the file. whatever we are now using printf and scanf. So for reading and writing to files, fprintf and fscanf. So here what we need to do, one extra parameter, that is the file pointer, needs to be passed. fputchar for writing one character, fseek function, it moves the file pointer to the position of the given location where we want to move the file pointers. Like in case of random access, we can use it, or we want to read from a specific location, we want to write to a specific location, then in that situation we can check the fseek function, it moves the file pointer to that location. Now which location we are going to move? So let's understand the syntax of this. It contains one file pointer, then the number of bytes to be moved, that is this, and then from which offset, from which location those number of bytes to be read. So that is one constant. So these constants are already defined in the stdio.h. Like seek set is the it moves the file pointer position from the beginning. Seek set means, like in this example, 21 bytes from beginning. Seek current means from the current byte, how many bytes we want to move. Seek end means moves the file pointer position to the end of the file and number of bytes from there. If we want to move backward, then in that situation we can write like fseek and like the file pointer, number of bytes, and seek underscore end. So it will move the 20 bytes backward from the end point. So ftell just gives the current position of the pointer, where the pointer is currently. Rewind is used to move the file pointer position to the beginning of the file, anywhere it is. So it will move back to the beginning of the file. So these are some functions which can be utilized for manipulation of files. Another, like one example for reading from the file, we have seen already one example for opening a file. So here we are having one file pointer and open it abc.txt in the write mode. Now if I want to input an integer, so we read one integer from the keyboard, and now we want to put this integer into the file. So we can do this using put w function also. Put w function is for writing to the file. So put w function we can use like fp comma the whatever integer we have taken. Here another, we can write using fprintf also. So we have passed fp, and formatted data is %d, that represents integer and followed by a new line character, and we have passed I. So this I will be written to the file along with the new line character. Now if we want to read from the same file, so we can use fscanf function, and it will be available in I. So we are reading from abc.txt being represented with the help of fp. So this is how we can read and write to the file. Now for reading from the file, there are some functions like fgetc, fscanf, fgetS, getc, ungetc. So these functions can be utilized. How to use, what is the benefit of using fgetc function? Fgetc function is used to take one character from the file. So it reads one character at a time. Every time we need to remind that we need to check whether the file is opened or not. And if that character is not null, that means some data is there. So that character we can utilize. Like here in this example, we are writing to the screen. We can write to some file also. We can do some calculation also. But we are reading here character by character. We are reading the content character by character. So for reading a content character by character, we can use the while loop, and we are reading one character, checking The loop will continue until it is null. So this is how we can read. We can read through fscanf also for formatted data reading. End of file I have already explained to you. So there is another function fgetS. fgetS function is for specialized for reading a line from the file. So the syntax contains one character pointer which will store the read data from the file. Number of bytes, maximum number of byte it is going to read, and through which file pointer it is going to read. So it is similar to getS, but getS is now deprecated. So we need to use fgetS. If we are going, fgetS can also be used to, this is interesting fact that fgetS is not only for reading from file. We can also use fgetS for reading from keyboard. What will happen if we want to read from keyboard? Then this will be replaced with stdin. So stdin is a file pointer which represents the standard input, that is our keyboard. So standard input. So whatever data we will give through keyboard, that can also be read using fgetS function. So it returns null if there is no data remaining. Like here in this example, fgetS, we are reading into a line. Line is a buffer or a character array of 1000 size. So maximum number what we can read 1000, and up to where it is returning null we are reading, and we are writing onto the screen. How many bytes it will read? It will read up to the new line. Wherever it will find new line, it returns and give line to the screen, print it. Again next line will be read. It will read up to where null is found. getC is being used for reading one character. So like here ch getC fp. So we are reading one character and we are checking end of file. And so this can also be used for like copying one file to another file. For copying one file to another file, what will happen? We will open one file in the read mode. We will open another file in the write mode, and we read character by character from file 1 and write. Rather than using this printf statement, what we can use fputc. That means we are putting to the file. So that will copy the content to the, so like here another example, I'll show how it is going to copy. So here we can use putc. This is the character which we are going to put, and this is the pointer. So one pointer we are using for reading, one pointer we are using for writing. So this is how we can copy the content of one file into another file. So that's all for today. In the next lecture, we will explore some more interesting facts about the file manipulation in C, like how to handle the non-ASCII data, that we will cover in the next video. Thank you all.